Hi children, we continue with our fourth chapter, carbon and its compounds. In the previous class, we started a discussion of chemical properties of carbon compounds, and under the heading we learned two reactions, combustion reaction and oxidation reaction. Now we are moving on to two more reactions. There are two more reactions, chemical reactions undergone by carbon compounds. Third one, addition reaction. So, addition reaction is undergone only by unsaturated compounds. What are unsaturated compounds? Compounds which contain a double bond or triple bond between carbon atoms. So, addition reaction is undergone only by compounds which contain a double bond or a triple bond between carbon atoms. So, unsaturated compounds add hydrogen. You need to learn addition of hydrogen only. There are several types of addition reaction, addition of hydrogen, addition of chlorine, addition of hydrogen chloride, like that. But 10th standard you will learn only addition of hydrogen to an organic compound, unsaturated compound, and addition of hydrogen to a substance is known as hydrogenation. Okay. So, unsaturated compounds add hydrogen in presence of catalyst, like nickel with the symbol Ni, or another metal, or palladium Pd, in presence of catalysts like nickel or palladium. Now, catalysts are substances which increase or decrease the speed of a chemical reaction. Catalysts are substances which increase or decrease the speed of a chemical reaction, but without taking part in the reaction. They do not undergo any chemical reaction here. They do not take part in the reaction. Their function is only to alter the speed of the reaction, increase or decrease the speed of the reaction. Okay. So, in presence of catalyst only this reaction take place, and what happens is the unsaturated compound gets converted to saturated compounds. So, addition reaction result in the conversion of an unsaturated compound into saturated compound. Addition of hydrogen to an unsaturated compound in presence of catalysts like nickel or palladium results in the formation of saturated hydrocarbon. Don't forget to write the catalyst above the arrow mark, because in the absence of catalyst the reaction will not take place. So, example we will write CH2 double bond CH2. This is the simplest alkene, ethene plus hydrogen. A molecule of hydrogen is added in presence of nickel or palladium. Now, look at this. I will write the structure of this compound. So, this is how, same way we write. CH2 double bond CH2, this is ethene. To this a molecule of hydrogen. What do you mean by a molecule of hydrogen? How many atoms are there? There are 2 atoms of hydrogen. So, one hydrogen atom adds on the first carbon and the other hydrogen atom adds on the second carbon. As a result, what happens? It becomes CH3, CH3. So, the single bond will change to, double bond will change to single bond. Okay. Out of the 2 hydrogen atoms in the hydrogen molecule, one adds on the first carbon and the other adds on the second carbon, making it CH3, CH3. So, the double bond naturally changes to single bond. So, what do you get? CH3 single bond CH3. The name of this compound is ethane. So, ethene changes to ethane. Ethene changes to ethane. Unsaturated compound changes to a saturated compound. Now, the next alkene CH3 CH double bond CH2. The name of this compound is propene. A hydrogen molecule is added in presence of nickel, or don't forget to write this, nickel or palladium. Then what happens? CH3 CH double bond CH2. One hydrogen will add to the, addition always take place on the carbons which are on either side of the double bond. Addition take place on the carbons which are connected by the double bond. So, one hydrogen will be added to the second carbon and the other hydrogen will be added to the third carbon. So, the carbons addition take place always on the carbons which are joined by the double bond. So, carbon 2 and 3 are connected by the double bond. So, What is the compound now? CH3, CH2, CH3. It is propane. So, propene changes to propane. Okay. So, the question will be, how will you convert ethene to ethane? Ethene is converted to ethane by the addition of hydrogen in presence of nickel or palladium catalyst. Next is CH triple bond CH, ethyne. This is also an unsaturated compound. So, a molecule of hydrogen is added to it in presence of nickel or palladium. So, what happens is, one hydrogen adds on the first carbon making it CH2, second hydrogen adds to the second carbon atom making it CH2. So, what happens to the bond? It becomes double bond. Again, a molecule of hydrogen is added in presence of nickel and palladium, nickel or palladium. What happens? CH3, single bond CH3. So, ethyne first changes to ethene, one more hydrogen is added, it changes to ethane. It changes to ethane. How can you write this reaction in a single step? CH triple bond CH plus 2H2. First step one hydrogen is added, second step also one hydrogen molecule is added. So, two hydrogen molecules in presence of nickel or palladium, directly you will get CH3 CH. So, overall reaction in a single step when you write plus 2H2. Actually, it is stepwise reaction. First step, ethane gets converted to ethene, then ethene to ethane. So, single step, ethane to ethane. Okay. Now, this reaction has an industrial application. This reaction, addition reaction, has an industrial application. This is used, hydrogenation in presence of nickel catalyst is used in the, addition in presence of nickel catalyst is used in the hydrogenation of vegetable oils. Hydrogenation of, this is the industrial application of hydrogenation reaction. Addition of hydrogen in presence of nickel catalyst is used in the hydrogenation of vegetable oils. Actually, the healthier cooking oil, animal fats generally contain saturated fats. Animal fats are saturated, they are considered to be unhealthy. It is said that they are harmful for health. Animal fats which contain saturated fats, saturated fatty acids, they are unhealthy and harmful for health. So, always for cooking we should choose vegetable oils which contain unsaturated fatty acids. So, oils containing unsaturated fatty acids should be chosen for cooking. Animal fats are saturated fatty acids and they are unhealthy, harmful for health. So, what is the application of not hydrogen, hydrogenation. Hydrogenation of vegetable oil. Application of addition reaction is in the hydrogenation of vegetable oil. Vegetable oils are unsaturated fatty acids. To that what we do? Hydrogen is added. So, what happens? They become saturated and unhealthy for, harmful for health. So, vegetable oils which are healthier, which contain unsaturated fatty acids, they undergo hydrogenation. Industrially, they are subjected to hydrogenation. Hydrogen is added to vegetable oils which contain unsaturated fats to convert them to saturated fats which are not good for our health. One such example is dalda. You might have seen dalda which is added to chapati, parota, etc. It is a substitute for ghee. Ghee is neyyy. It is an animal fat. So, a vegetable substitute for ghee is dalda. It is tastier, but it is not that healthy. A vegetable oil which contains unsaturated fat is hydrogenated and it is converted to saturated fat. Dalda is such an example. So, this is the application, hydrogenation of vegetable oils using nickel catalyst. So, during this process what happens is vegetable oils which contain unsaturated fats are converted to saturated fats which are not good for health. This is done in presence of nickel catalyst. Now, the fourth reaction we will learn, substitution reaction. You are familiar with substitution. If a teacher is on leave, another teacher comes to the class during that period, that is substitution. So, what is substitution? One replacing the other, one in place of other. Okay, that is called substitution. This is a reaction undergone only by saturated hydrocarbons. saturated hydrocarbon, and substitution with chlorine only you have to saturated hydrocarbons undergo substitution with chlorine in presence of sunlight. So you have to learn substitution reaction of saturated hydrocarbons. Saturated hydrocarbons undergo substitution with chlorine in presence of sunlight. In this reaction, the hydrocarbons, the hydrogen atoms in the hydrocarbon are removed one by one. Hydrogen atoms are removed one by one, substituted one by one. So we will write it with methane. Substitution reaction of methane with chlorine in presence of sunlight. So, one hydrogen atom in methane, it has 4 hydrogen atoms. One of the hydrogen atoms in methane will be replaced by chlorine atom, Cl2. It is a chlorine molecule containing 2 chlorine atoms. One of the hydrogen atom of methane will be replaced by a chlorine atom. So, what will you get? CH3Cl. See, instead of CH4, one hydrogen is replaced by a chlorine. So, you get CH3Cl. What is left is one hydrogen which is replaced from methane and one chlorine which is there in chlorine molecule. Chlorine molecule contains 2 chlorine atoms. One is used for substitution, other one is free. It combines with hydrogen. Hydrogen chloride is formed. Now, the name of this compound is chloromethane. So, methane changes to chloromethane. Okay. Now, this chloromethane, again substitution with chlorine in presence of sunlight. So, what happens? Again one hydrogen is replaced. So, it had 3 hydrogen atoms. One hydrogen from these 3 is removed. So, it becomes CH2Cl2 plus HCl. Then, its name is dichloromethane. Dichloromethane. Then CH2Cl2 plus Cl2 in presence of sunlight. Now there are 2 hydrogens left. Out of that, one is replaced. So you get CHCl3. So that hydrogen which is replaced and one chlorine from chlorine molecule make it HCl. This name is trichloromethane. Trichloromethane, or simply known as, commonly known as chloroform. Chloroform you might have seen, use of chloroform you might have seen in movies and all. It is used to make a person unconscious. So, CHCl3 plus Cl2 in presence of sunlight. Now, there is only one hydrogen atom that has to be substituted. So, that is also removed. It becomes CCl4 plus HCl. The name of this compound is carbon tetrachloride. Carbon tetrachloride or tetrachloromethane. Carbon tetrachloride. This is an industrial solvent, organic solvent. So, all the hydrogen atom of methane are replaced by one all the hydrogen atoms are replaced, and finally you get carbon tetrachloride. In one step, how can you write this equation? CH4 methane plus how many chlorine molecules are added? 4. So, 4 chlorine molecules are added. So, what do you get at the end of these 4 steps? CCl4 plus how many HCl molecules? 4 HCl. This is how we can write this reaction in one step. So, actually hydrogen atoms are replaced one by one, but this reaction is a very fast reaction, take place within fraction of a second, but the overall reaction we can write as methane CH4 plus 4 Cl2 giving CCl4 plus 4 HCl. Now, can you write the equation for another saturated hydrocarbon? This is ethane. C2H6 is ethane. So, what happens if a chlorine molecule is added to ethane in presence of sunlight? One of the hydrogen atom of ethane will be replaced by chlorine atom. You will get HCl. I hope this HCl, formation of HCl is clear to you. One hydrogen that is removed from the hydrocarbon H, one chlorine that is left in chlorine. Out of Cl2 only one is used for substitution, the other one they combine and form HCl. So, you get chloroethane. chloroethane is formed. How will you convert ethane to chloroethane? By substitution with chlorine in presence of sunlight. Okay. So, with that the chemical properties of carbon compounds is over. I hope it is clear to you. So, that is all. Thank you children.